right? So the next important concept is narrowband frequency modulation. So based on the beta factor value, so there are two cases. So one is narrowband frequency modulation and the second one is wideband frequency modulation. So in that, first we have to discuss the narrowband frequency modulation. So according to the single tone frequency modulated wave, so that is given by S of t is equals to AC cos of 2 pi fct plus beta sin 2 pi fmt. So here is AC cos of 2 pi fct plus beta sin 2 pi fmt. So S of t is equals to AC into, so the cos function is multiplied in each value. So that is AC into cos 2 pi fct cos plus cos beta sin 2 pi fmt minus sin 2 pi fct plus sin of sin beta 2 pi fmt. So by simplifying that above equation, so it can be written as S of t is equals to AC cos 2 pi fct minus beta AC sin 2 pi fct sin 2 pi fmt. So which can be expressed in detail. That means S of t is nearly equal to that AC cos 2 pi fct plus 1 by 2 beta AC cos of 2 pi fct plus fm into t minus 1 by 2 beta AC cos of 2 pi into fc minus fm into t. So the above expression for NBFM is similar to the single tone amplitude modulated signal. So the NBFM expression, that means S of t expression, is similar to the single tone amplitude modulated signal. సో ఈ ఎన్బిఎఫ్ఎం యొక్క రిజల్టెంట్ సిగ్నల్ ఎస్ ఆఫ్ టీ సిగ్నల్ ఎలా ఉంది అంటే మనకి, సో ఏదైతే మనం సింగిల్ టోన్ యాంప్లిట్యూడ్ మాడ్యులేటెడ్ సిగ్నల్ జనరేట్ చేసినామో దానికి సిమిలర్గా ఉంటుంది ద అవుట్పుట్ ఆఫ్ NBFM signal. But the modulated signal produced by narrowband modulator of the above, so it differs from the ideal condition in two fundamental respects. So what are those? So first fundamental concept is, so the envelope contains residual amplitude modulation and therefore it can varies with respect to time. And second one is, for a sinusoidal modulating wave, the angle theta I of t, it contains harmonic distortion in the form of third and higher ordered harmonics of the modulation frequency FM. So however, by restricting the modulation index to beta value less than or is equals to 0.3 radians, so the effect of residual AM and harmonic PM are limited to negligible the levels. So then what is the expression of NBFM? So the expression of NBFM is similar to corresponding one defining an AM signal. So that is follows. So S of t is equals to AC cos 2 pi fct plus 1 by 2 beta AC cos 2 pi into fc plus fm into t minus cos of 2 pi fc minus fm into t, that is represented as narrowband frequency modulated signal. Similarly, the single tone amplitude modulated signal S of t is equals to AC cos 2 pi fct plus 1 by 2 mu AC cos 2 pi into fc plus fm into t plus cos 2 pi into fc minus fm into t. So in case of, right, so comparing the two equations, that is S of t signal in NBFM and S of t signal in amplitude modulation. So what is the basic difference between these two signals of AM signal and NBFM signal is, so the lower side frequency in the NBFM, the sign is reverse. So S of t is, so the lower side frequency minus representation, and in amplitude modulation, that is the sign is plus representation. So that's why the NBFM signal is essentially requires the same transmission bandwidth as the AM signal. So what is the transmission bandwidth of AM signal and NB-FM signal is, that is 2 FM signal. So that is about the narrowband frequency modulation. So what is the phasor representation? So what is the basic difference of this AM signal and NB-FM? So these two signals are represented the phasor comparison by using the phasor comparison. So here a phasor comparison of NB-FM and AM waves for sinusoidal modulation. So here the first one represented as NB-FM wave, and the phasor representation of NB-FM wave, and the second figure B represents the phasor representation of amplitude modulated wave, right? So the phasor diagram of NB-FM wave is shown in figure A. So the resultant of two side frequencies phasor is always at right angles to the carrier phasor. So this is represented as upper side frequency and lower side frequency, and sum of side frequency phasors, and we are having the carrier signal. So that is represented as resultant signal. So the resultant of two side frequencies of the phasor is always at right angles to the carrier phasor. So the phasor diagram of NB-FM representing the narrowband FM wave, so which is approximately of the same amplitude as the carrier wave. So ఈ phasor diagram representation of NB-FM లో, so narrowband FM wave which is approximately the same amplitude of the carrier signal. సో క్యారియర్ సిగ్నల్ యొక్క ఆంప్లిట్యూడ్కి సేమ్ ఉంటుంది. సో ద ఎఫెక్ట్ ఆఫ్ దీస్ ఈజ్ టు ప్రొడ్యూస్ ఏ రిజల్టెంట్ ఫేజర్. సో బట్ అవుట్ ఆఫ్ ఫేజ్ with respect to it figure B, so that is amplitude modulated phasor. It represents the phasor diagram of amplitude modulated wave. So the resultant phasor representing the AM wave has an amplitude different from that of the carrier phasor, but it is always in phase with it. So here is we are taken, so upper side frequency and lower side frequency, and the two sum of side frequencies, that is carrier frequency. So here the carrier phasor is always in phase with the amplitude modulated wave. So this is about that narrowband FM wave and wide amplitude modulated wave phasor comparison techniques. Then how to generating this narrowband frequency modulated wave? So this is the block diagram representation of narrowband FM generation. So here is we are taken the modulating integrated circuit. So then after we will give, so before that the relation between the FM and PM wave. So at the time we are having the integrated circuit, then it will be generated. So like this. So here is FM wave generation using the phase modulator. So here is we are taken two circuits. So one is integrated circuit and second one is phase modulator circuit. So the integrated circuit are having the modulating signal. The resultant of this integrated circuit will gives to the phase modulator circuit. So the phase modulator circuit are also having one more input, that is AC cos 2 pi FCT, and the resultant signal is FM wave. So like this we are having to generate the signal. So here is the modulating wave, that is integrator. So that gives to the product modulator. So here we are represented one product modulator, and that is 90-degree phase shifter, and the summing junction minus and plus, so represented as narrowband FM. So carrier wave AC cos 2 pi FCT. This is the block diagram of a method for generating a narrowband and FM signal, right?